Hello, let's evaluate two problems today. That is, I of a equal to double integral x square plus y square less than or equal to 1 e power ia into x square plus y square dA, and here a belongs to R. The second case is limit a tends to 0 I of a. So in the first case, as you can see, this is e power ia of x square plus y square, right? So it's very easier to do it in the polar coordinates. So in polar coordinates, x equal to r cos theta, y equal to r sin theta, dA equal to r dr d theta. So for this case, I of a equal to, let's construct this first. This is x and this is y. This is origin. This is 1, radius of 1. What they have said is x square plus y square less than or equal to 1. I mean, this is this area. That is, it is covering this area. Then here theta is 0 to 2 pi, as it covering the full circle. R value is integral 0 to 1 e power ia x square plus y square is r square. Then dA is r dr d theta. Fine. Here then I of a equal to, as you can see here, d theta. You can just integrate it, keep it out. Integral d theta is theta, and when you substitute the limits, it will be 2 pi minus 0, which will be 2 pi, and we are left with 0 to 1 e power ia r square r dr. Fine. Here let's consider r square equal to u, then 2r dr equal to du. That is, r dr equal to half into du. Then let's calculate the integration limits. If r equal to 0, then u equal to 0. If r equal to 1, then u is 1. That is, integration limits are not going to change. Then I of a equal to 2.2 integral 0 to 1 e power iau r dr is half into du, which is pi into integral 0 to 1 e power iau du. So now you will see here the first case. For a not equal to 0, you will know why we are taking I not equal to 0. It will be I of a equal to pi into e power ia u by ia, and the integration limits are 0 to 1. Then this is pi by ia e power ia minus e power 0 is 1. That is, I of a is pi into e power ia minus 1 by ia for a not equal to 0 plus. As you can see here, if a equal to 0, it will be e power 0 minus 1, which is 0. Then ultimately there is ia. When ia equal to 0, it will be 0 by 0. It is undetermined, right? For this case, a not equal to 0, this will be the case. What happens for a equal to 0 case? That is, which was asked in the second question. Limit a tends to 0. I of a is, which we can write as pi is a constant, and keep it out. Then this will be limit a tends to 0 e power ia minus 1 by ia. As this is getting a form of 0 by 0, then you can use L'Hopital rule. Then let's just differentiate it. Then this will be pi into e power ia into I minus 0 by I, which is pi into uh, e power ia into I by I. this will get cancelled. Sorry, there is limit a tends to 0, limit a tends to 0. When a tends to 0, this will be pi into e power 0. E power 0 is 1, then this will be 1. Finally, the two solutions are, in our case, I of a is pi into e power ia minus 1 by ia for a not equal to case, right? When this limit a tends to 0, I of a is pi. Fine. These are our two solutions.